A very good afternoon to our speaker today, Mr. Teo Hui Jian, and all attendees in the room. Welcome to the webinar session organized by Chemical Engineering Undergraduate Club, University of Malaya. I am Janardhan and I will be your moderator for today. I hope everyone is doing well and in good health in these challenging times. On behalf of CEUC University of Malaya, I'd like to thank everyone here for spending your time with us today. We had received an overwhelming number of responses for this event from our own students, as well as students from other universities. Thank you again for your support. Before we start, kindly allow me to briefly introduce our speaker, Mr. Teo Hui Jian. Mr. Teo Hui Jian graduated with a Bachelor of Chemical Engineering from University of Malaya. He joined Tialog Group as a process engineer in 2019. His job scope includes coding and automating mass and energy balance calculations for thermal oxidizers and incineration plants. Currently, he is assigned as a project manager for a FEED feed project in chemical industry. In his free time, Mr. Hui Jian writes codes and serves as a community teaching assistant CTA for edX Principles of Manufacturing MicroMasters, a free open online course by MIT. Previously, he was part of UniChat, an app with over 5,000 downloads on App Store and Google Play Store. He has received numerous awards, including the Institution of Engineers IEM Award, Excellent Student Award, and the prestigious Muhammad Zaki Sulaiman Memorial Award, including numerous wins in NACES. It is our great honor to have Mr. Teo Hui Jian as our speaker today. There are a few reminders before we proceed to the talk. Firstly, please mute your microphone while the talk is ongoing. Secondly, if you have any questions during the presentation, kindly type your questions by visiting the Mentimeter website with the code 8654-6287 or by clicking the link provided in the chat box. The questions will be answered during the Q&A session later. The questions that had been stated in the registration form earlier are already in the Mentimeter app and will be brought forward in the Q&A session as well. Without further ado, I pass the floor to Mr. Teo Hui Jian to start the webinar on Python for beginners. Please welcome.
Thank you, Kanatan. Thank you for the extremely warm welcome and generous introduction. So let me just share my screen here. All right, before I start the webinar, I just want to make sure that everyone can see me and hear me well. If you can see me and hear me well, please type in the word snake in the chat box. Please type in the word snake in the chat box. All right, I see there are a lot of snakes here. All right, so I'm pretty sure that you guys can hear me and see me well. All right, so let's not waste any more time. Let me just start with this presentation now. So thank you, Chemical Engineering Undergraduate Club, for inviting me. So I was pretty surprised when you guys approached me for a Python webinar. But anyway, here we are, and thank you very much for joining. So today my topic will cover a little bit about myself, the common myths about programming, what is the basic syntax of Python, and also a few hands-on examples. So let me just show you how many registrants are registered for the webinar. So if I'm looking at the form, I see people from about 14 countries. We have Mexico, UK, Algeria, Nigeria, Zambia, Lebanon, Pakistan, India, Malaysia, Singapore, Indonesia, Philippines, Vietnam, Japan, and Australia. So give me a shout out in the chat box if I miss any of your countries. But to all the participants from all over the world, good morning, good evening, good night, wherever you are from. All right. So a little bit of myself. So I was a student from University of Malaya. So my university life was pretty interesting. I managed to get a visit to a Shell platform. Malika is offshore of Sabah. So now it's currently in Sabah. I joined a few times on a National Chemical Engineering Symposium. So I also joined IOM Disrupt, which is a 24-hour hackathon. And that actually inspired me to start coding, because that hackathon usually involves some coding in a very short time. And I was a director and now advisor of the Regional Chemical Engineering Undergraduate Conference. And just to diversify a little bit, I joined a national intervarsity Chinese literature competition, just to diversify my experiences a little bit. So my kickstart into programming started when my friend Fu, he asked me to join him in his app called UniChat. So UniChat is available in Google App Store and Apple App Store. It has about more than 10,000 downloads as of now. So you guys can check it out if you guys would like an app that actually benefits university students. But it's more on the Klang Valley. Currently, it's more on the Klang Valley, and we are still thinking about how to expand it, I believe. So what do I do now? So I'm a process engineer. So what a process engineer does is we calculate mass and energy balances. We do process design, process synthesis, simulation. And mass and energy balances is something that we can easily automate by using coding, because mass and energy balances otherwise is very boring to calculate and also very tedious to calculate by hand. So my company, Tialog Environmental, is actually an environmental engineering company. So we do gas and exhaust treatment, we do incineration, thermal oxidation, high temperature technologies, and we also do some wastewater treatment technologies. So in my free time, I run a Facebook group called Chemical Engineering and IR 4.0, just to share some knowledge I have on what is Industry Revolution 4.0. Knowing how to code is one of them. And currently it has about 6,000 members, I believe. So if you should join the group, I'm going to drop this this link here, so you guys can have a look if you guys are interested. And I also frequently write stuff on LinkedIn. So what happens is I write things about Excel VBA, I write things about Python on LinkedIn. So you guys can follow me on LinkedIn if you guys are interested in this kind of stuff. So let me just tell you a little bit about what is Python. So Python is a snake. All right, it's a snake. Its family name is Pythonidae. It has 10 genuses and 42 different species. So what a python does is that they lunge around on trees and do nothing every day. They are cold-blooded animals. They eat prey, they hunt prey. And the main way they kill prey is by constricting them. That means they wrap themselves around you and they squeeze you to death. Basically, that's what they do. And there are many varieties of pythons. Some can go up to 15 feet in length. So you can see this giant python here. It is 15 feet in length. And pythons have the ability to lunge forward and bite at you. All right, so that they are very dangerous creatures. Wait a minute, I'm seeing someone in the chat box telling me that they are not here to learn about snakes. Okay. So obviously, they are not here to learn about snakes, but just to let you know a little bit about what Python is. All right. So what is Python? Python, as I mentioned before, is actually the name of a snake. It's also the name of a gun. If you are familiar with the games Hunt Showdown, Half-Life, you see this gun called the Python. And it is also a high-level programming language. I will not go into details about what constitutes a high-level or low-level programming language today, because that's beyond, that will take a very long time to discuss. But I'm just going to call it an object-oriented high-level programming language. And that's actually what we are here to know about today. So the common myths about what programming is that there are a few common myths that I know of. The first is that Python is just something that we use for fun. But in reality, Python is used in very, very serious kind of applications like machine learning, artificial neural networks, etc. Number two, a lot of people think that programming is just for computer science students. Well, I'm an engineer, so why the heck am I doing programming? In reality, engineers do use programming, even chemical engineers. Like most of us know MATLAB. So MATLAB, you do need some programming knowledge to learn how to use MATLAB effectively. Some people know how to program in Excel, known as Excel VBA. And there are also more and more people using Python for machine learning applications in chemical engineering. Programming is only for nerds. Now that's the biggest one. But in reality, you don't have to be a true nerd to do programming. As long as you can turn on a laptop, you can do programming. It's not rocket science. It's basically anything anyone can just pick up easily. And finally, there's a common myth that you need special software for programming. It's very difficult. But in reality, you can do programming anywhere. As long as you have a laptop, as long as you have the internet connection, you can do programming. So it's pretty simple. So there are quite a number of common programming languages in the world. There are like at least 20 or 30 of them if you consider all forms of programming. So the most common programming language is Python, followed by Java. So Java is something that is usually used for app development. For example, Android apps, they often use Java or some derivative of Java. So this is, I believe this is what you call Node.js. Node.js is also another for web development applications. So you have C++, which is the traditional C, and C++ is a traditional old kind of traditional programming language. And there are many, many others. There's even MATLAB in here. So I would say that Python is the easiest to get into because it has a lot of user-friendly options. But since most of these languages are pretty similar in terms of syntax and the rules, so if you get into Python, it will help you to pick up any other language. So what is Python, the programming language? First released in 1990. Open source, is an open source language. The current version is 3.92, I believe. But as long as you are using a version that's 3 point something, it should be pretty common. If you are using a Python version 2 point something or 1 point something, a lot of the code is different and you probably not work properly in the new Python language. So in order to use Python, you need an integrated development environment, or IDE. Later I will show you what an IDE is. And finally, Python is an object-oriented programming language. This means that you can create your own objects, custom objects, classes, inheritance, methods, and so on. So the definition of what an object-oriented programming is a bit far away from what today's webinar is about. But if you wish to know more, maybe we can connect and I can tell you more about what is an object-oriented programming language. So for today, we are not going to use the object-oriented programming language features of Python. So let's have some interaction just to make sure you guys are still logged on and not AFK or something. So I'm going to launch a poll. Let's have a look at what you guys think is the source of the name Python. So you can see the poll on the screen now. So let's have a look and you can choose what is your choice. So where do you think the name Python comes from? Is it from a snake? Is it from some long dead Greek philosopher 2,000 years ago? Is it from a comic book that you never heard about? Is it from a TV show? And is it from a place? So maybe there's a place called Python somewhere in the world. I have no idea. So let you guys decide. Where do you think Python, the name Python, the programming language comes from? So let's give you about 30 seconds more. Let's just see how many people think. So I see most of you are thinking that Python comes from a snake. Okay. So I think 1/3 of you pick a Greek philosopher. Do you know any Greek philosophers named Python? Comic book. Okay, some people chose comic book. Some people chose, I think about 10% of you picked a TV show. And let's see. All right, so I give you guys more about 20 seconds more. And let's see any one of you guys still have any opinions or any ideas about where this name Python comes from. Okay, so I see about 80% of you guys have voted. So I'm assuming the other 20% is AFK or above, away from keyboard. So I guess organizers maybe can close down the poll now and we can continue. All right, so I'm going to share with you where the name Python comes from at the end of the webinar. So make sure you guys stay until the end. Yeah? So, but I can give you a hint. It's actually not from the snake. It's actually not from the snake. Yeah. So let's get into some hands-on knowledge of what Python is for. So Python is actually common for many industry revolution 4.0 technologies, like artificial intelligence, neural networks, natural language processing. So natural language processing is how you transcribe speech into text. So for example, if you are on YouTube and you have ever used the subtitle function, then you have used natural language processing. So an AI will actually detect what the person is speaking and translate it into English or Spanish or whatever language that you choose in the subtitles. Pattern recognition. So pattern recognition is something like facial recognition is one type of pattern recognition. It's also used a lot in manufacturing. For example, in Vitrox, which are sort of the forefront leaders in Malaysia. Big data analytics or data science is a common thing nowadays. So you can infer trends, you can fit into curves, you can create a linear regression model or even higher level regression models for your data. And finally, machine vision. So machine vision is by using a camera and an automated production line, you can easily detect if some parts, for example, you are creating automotive car parts, and you want to know if these parts are actually damaged. So you can have a machine that's actually look at these parts and actually pick out all the damaged parts by themselves. And many of them actually operate by using machine vision technology, which is a part of artificial intelligence. So what is a Python IDE? So one common Python IDE that I know of is called Spider. So Spider is open source. It's part of Anaconda. So Anaconda is a Python development package that you can download from the internet. But today we are not going to do that because installing it does take some time. So I'm going to use an online version of an IDE. So this online version of the IDE is called wrapper.it. So wrapper.it is basically free for everyone. You guys can just log into it right now. So I'm going to share the link in the chat box and you guys can have a look. So you guys can actually open it in your browser right now and you guys can have a look. So I'm going to share with you an example of how it looks like. Just make sure you guys are on the right track. So let me just stop new share for a moment. All right, so you guys can see my screen now. So I'm sharing the website, wrapper.it.com. And if you see it, you can log in for Google account. Otherwise, you can just run it like that. And you can click on create wrapper here. And it will bring you to the actual coding screen. So this wrapper.it is using Python 3.8.2, which is one of the newest. It's not the newest, but it's probably suitable for our case. So we can see that there are two parts. The left side is the Python file, py file, and this is where you write down all the functions that you are going to use later on. On the right side is the console. So in the console is where you type in codes that you want to execute now. So for example, I can actually just execute some code here. I can do some mathematical operations here, and I can do some Boolean operations here. For example, I can assign x equals 2, x equals 2, something like that. So this is where I execute the code that I want to run now. So we are going to leave it here. I'm going to leave it here, and I'm going to go back to the slides, and I'm going to show you some examples of how to use Python from the basics. All right. So before you continue, I'm going to suggest that you guys download a copy of the examples that I'm going to use later on from my short form link. So I'm going to put the link in the chat box, and I'm going to also upload the files that required, so you guys it's easier for you guys. And so you can either choose to download it from the link or from the for the chat box. So let me just give me some few seconds, and I'm going to upload it in the chat box. All right, so I'm going to upload to you inside the chat box the example Python files and also the slides for today. In case you miss any slide and you wanted to follow it immediately, you can have it from the chat box. Yeah. So let me know if you have any trouble downloading or saving the files onto your computer. If you have any trouble, please let me know in the chat box. Yeah. So I hope everyone is able to download it. It doesn't matter if you don't have it, you can get it later, but I guess it's better if you can follow along as just to have a hands-on, more hands-on kind of exercise. Yeah. So let me go into the basics of Python. So I talked a lot about introduction, about programming, about Python, about applications, and so on. So now it's time to actually go into the actual details of what Python is. All right. So Python is actually a very simple programming language. It is arguably the easiest to learn. And because it only consists of 4 main components. If you know how to use all 4 main components, you are a Python expert. Technically, there's a 5th component called objects, as it is an object-oriented programming language. But I'm not going to touch that because that's a more deeper subject. So we are going to focus on the 4 basic components of Python. So first of all, you have variables. So a variable is something that is a container that you create. After you create this container, you can store information inside this variable. After you have information stored inside variables, you can manipulate them by using operators. After you have manipulated them, we want to have this manipulated data as an output or as an input to something else. That is how we do functions. That is what we call functions, where we have some input, and this function will then create some outputs that is useful for us. Finally, we have some branches and loops. So functions use branches and loops in order to decide when to carry out what action. So I want, if something happens, do something. Otherwise, do something else. So this is one example of a branch and loop. So if you know all 4 of these, you are a Python expert. Just to put it very simply. Yeah. So I'm going to go to a few examples of each component. So the first is a variables. So there are 4 main data types in Python. A data type is basically a kind of variable that you use. It's a string, integer, boolean, and float. So a string is basically any kind of text. For example, hello world or foobar. Foobar is sort of a joke in the computer science field, where it's used to represent something meaningless. So exclamation mark is also a string. And empty space is also a string. So if I type in the space bar and nothing else, it is a string. All right. So an integer is any number, any round number. So you can have positive, we can have negative, we can have 0. A Boolean variable is either true or false. So sometimes you want to know whether something is true or false. So you will use a Boolean variable. So a float is a number. This is what you call a floating point number. And this allows us to have decimal numbers. So Python does have a very large range of decimal numbers, but Python does have a weird quirk that it does not calculate certain values accurately. For example, you have a number that has 300 decimal points. It's only going to calculate the first 10 or 20 or something like that. And so you might have some issues later on, but I'm going to touch on that in one of the examples. Yeah. So we have a complex number. So this is for certain what you call engineering applications. So you can have 3 plus 2j, 1 plus 5j, and so on. Do note that Python uses j, not I, as a complex in the complex number. So if you type in 3 plus 2i, something wrong might happen, depending on what IDE you use. So it's better to use j. And you can also have a none type of variable. So none means something like not defined. That means you didn't define this variable, so it's going to show as none. And there are also certain special variables called list, tuple, dictionary, set. So all these are actually collection of elements. So the elements themselves can be any of the above variables, except for none, because that's not going to make any sense. But you can have a collection of variables and you can actually manipulate them. So a list and a tuple are about the same, but I'm not going to go into details about what the difference is. If you want to know that actually a tuple is not mutable and a list is mutable. So what is a mutable, not mutable is beyond the scope of today's discussion. So I'm going to go into the wrapper.it console, and I'm going to show you some examples of variables. So let me just go back to my console. And I'm going to just share this screen here. So let me just, all right. So I guess you guys can see my screen now. So I'm going to show you some examples. Okay, Okay, so I'm going to type in these examples in the console. So first, I'm going to clear out this old data here. So I'm going to type in the word clear. Oops. Oh, it doesn't work here. Then let me just try to rerun it. Okay, so now this is there's nothing else here. But if you are using a local IDE, you can just type in clear, CLEAR, and it will remove all the previous whatever that has been in the console. So let me just assign a variable. Let's say I use the keyword x equals to full bar. So I can show this variable by typing print x. So it's going to show the variable value, which is full bar. And I can also type in type, where the type function will then tell me what type it is. So this is a string type variable, class string. So we can have a number, we can have y be a number. Let's say y equals to 2. I can print out y. So it shows 2 in the console. And I can also show y. What is the type of y? So it's an integer. So let z be 2.136, just to have some random number. And I'm going to type in type of z. So this is a float type variable. So let's have some crazier ideas. For example, let's have a equals to 2. And let's have a type of a. So we have a Boolean type variable. So let me show you one example of a tuple. So a tuple is a collection of elements. So let's say I have a list equals to open bracket, close bracket. So open and close brackets represent tuples. So I can type in 1, comma, 2, comma, 3, comma, and let's just have A, B, C, just to mess it up. So this is a tuple. So I can just type in type list. So it shows a tuple object class. Yeah. So this is a few variables that we are using. But of course, variables themselves are pretty much useless unless you can manipulate them. So that is going to be our next part of the discussion, which is about operators. So let me know if you guys think I'm going too fast. If I'm going too fast, let me know in the chat box if this pace is okay for you. If it's too fast, let me know. I can slow down a little bit. Yeah. So let me just go to the next one. Operators. So operators are how you manipulate variables to get what you want. So basically, we have the standard mathematical operations, plus, minus, multiply, divide. We can have exponent. So to be careful, in Python, exponent is represented by two asterisk symbols. We can have modulus and integer division. So later I will show you what modulus and integer division means. We can have equal as an assignment. So if I say x equals to 2, that means I assign the value x to 2. Sorry, I assign the value 2 to x. That means x is now 2. And if I want to know whether x is equal to something, I use the double equal sign, which means comparison operator. Is it equal to something? Exclamation mark and equal is not equal to. And for comparisons, you can have less than, greater than, less than or equal to, greater than or equal to. And you can also manipulate Boolean operators by using and, or not. So basically, and or, some people get confused. So and basically will give you an answer true if all clauses are true. Otherwise, false. For or, the answer will always be false if all clauses are false. Otherwise, it will always be true. So sounds confusing, right? So let me just show you a demonstration about some simple operations. So let me just go back to my window. Okay. So let me just show you, let me just clear this. And let me just show you some operators. Yeah. So let's have x equals to 2, y equals to 1, enter. So let's have z equals to x plus y. Sorry. So if you make a mistake in a console, you can just press the up arrow key. So press up on your keyboard. It will show you the last input. So for example, I can just quickly just edit it. And I will get the x plus y. And then I will save the value inside the variable z. So I can show you the type of z. So it's an integer. So if you add two integers together, it will always be an integer. If you add an integer and a float, the resulting will be a float. If you add two floats, the resulting will also be a float. So that's how Python actually analyzes this. So I can print z. So this will show the value of z. So you get 3. And you can do more manipulations. For example, let's have something new, different. So let's say I have a equals to 2, b is equal to 2 squared. So in order to do the exponent, so 2 squared is the exponent, 2 exponent 2. So you have 2 double asterisk 2. So you have saved this inside b. So I have print b. So you get 4. Yeah, so simple as that. And let's have some more weirder, for example, modulus. So let's say I have 10 modulus 3. You get 1. 10 integer division 3. You get 3. So modulus and integer division are related. So basically, it's like doing very primary school or elementary school maths. If you just 10 divide by 3, you get 3 remainder 1. So remainder is a modulus function. So the modulus function gives you the remainder of the division. Integer division gives you the answer without the remainder. So you get 3. So what is the importance of integer division and modulus? Modulus is a good way to know whether a number is even or odd. Because if it's an even number, the modulus will always be 0. If it's an odd number, the modulus will always be 1 if you divide by 2. So for example, if I get 13 modulus 2, I get 1. So this means this is an odd number. If I get 14 modulus 2, let's say 14 modulus 2, you get 0. So modulus is usually used as a test of whether a number is odd or even. And we can have other let's say Boolean operators. Let's say x equals to true, y equals to false. When typing in Boolean operators, the capitalization must be correct. Otherwise, it will detect as a string. Okay, so let's have x. Let's compare if x is equals to y. So you get false because x is true, y is false. So you can have, let's have some number comparisons. A equals to 2, y equals to 1. Is A equals to 2? Is A equals to 2? True. Is A equals to B? False. Is A equals to 2 or A equals to B? You get true because one of them is true. Yeah. And let's say if A equals to 2 and A equals to B. So you get false because one of them is false. So this is how Boolean operators work. You can also use not. For example, not A equals to 2 and A equals to B. So you get false. Or not A equals to 2 or A equals to B. Oops, sorry. So you get false. So that's how the Boolean operators work. Yeah. So this is a basic introduction on Boolean operators, and a lot of this is used in certain logic kind of applications where you want something to happen if something is true. You want to compare if this is true and this is also false. What should you do? So these operators are used in these kind of cases. Yeah. All right. So let me just go back and see. Let me just go back to my slides. So I'm going to share my slides here. Okay. So let's get into the main part of what Python is for, and that is functions. So a function is a set of operations that I want to execute at certain times. And to execute this function, I need an input. And I also need an output. So the output is produced by the function. If you don't have an output, the function will output none as a function. So a function can accept arguments. So argument is the inputs of the function. And in Python, we use indentation to explain or to decide whether an operation falls under a function or not. So I'm going to show you how indentation works in Python. So Python is an indentation language. If you do the indentation wrongly, it will not execute the code properly. And Python is different from other languages is that you don't have to declare any variables before you use. For example, I want to use X. I don't have to declare X as a string variable. I don't have to. I just directly assign X equals to 2. So Python automatically decide, okay, 2 is an integer, so x is also an integer, simple as that. So Python is considered a very simple language because of this. You can actually take a lot of shortcuts when it comes to programming. So let me just show you this function here, which is called def. So def is a keyword when we want to define a new function. So greeting is the function name. So greeting is the function name. This variable name here is the input. And in this case, name is a string. So usually when we define a function, we are going to type in this triple what you call quotation marks. And we are going to write in something. So whatever that's written between these sets of triple quotation marks is for our reference. It's not for the Python compiler. So Python will not read it. It's for my reference. So for the coder or for whoever you want to show this code to. So this is what we call the docstring. So the docstring is a reference to tell you what is the function about. And the function can have other operations, but in the minimum, for minimum, the function needs to have a return string. So return is the output of the function. So it's going to return hi, the word hi, plus the name of the person that actually executed this, for example. So let me just show you how I'm going to code in this function in the REPL IDE. Okay, so I'm going to clear this console here. And I'm going to write in the function. So for functions, I write in the left side, in the left box. So I'm going to define a new function. So I'm going to define greeting. Open bracket, close bracket, colon, semicolon. So now I define a function. You realize that Python has actually indented my my cursor slightly. So I'm actually 2 spaces into the line. So this is how indentation works. So anything that's written 2 spaces into the line is under the greeting function. So I'm going to type in the docstring here. So I'm going to type in triple quotation marks. And this is the docstring. So input is a name, a string. Output is a string. So I'm going to close this docstring here. And type in triple quotation marks as well. And I'm going to type in the return statement inside this function. So return, open bracket, hi, comma, space. So remember, spaces are considered as part of the string. So you must have the space. Otherwise, later your output, you'll be missing a space. So plus the name. So this function is fully defined, so I can run it. And nothing happens because I have not asked it to do anything. So to call this function, I'm going to type in the function name. So greeting, open bracket, and this function needs 1 argument, which is name, which is a string. So I'm going to give it a string, for example, Dave. So because this is a string, you need to enclose it in either single quotation marks or double quotation marks. So both of them can work, but it must be consistent. So if you start with a single mark, you must end with a single mark. So simple as that. So I have call this function, close bracket, and I press enter. Oops, sorry, I forgot to define the name as an argument. So let me just rerun it. And let me just call the function again, greeting Dave. So it shows the return hi Dave. So you can see that it prints exactly as I define it, including 1 space after the comma. So that's how it works. Yeah. And let's say if I try to call the function with something that is not expecting. For example, I call greeting with 2 as a number. You're going to get a type error. So type error means that you have a mismatch of what the function is expecting and what the function is supposed to output. So you can have some. So in a single Python file, you can define multiple functions. For example, I can define another function, but I have to go out to the outer layer. So I'm going to click press backspace and enter. So it's going to go back to the outer indentation, and I'm going to define a second function. Let's call it throw name. Okay. So this is going to be the throw function. Input, name, a string, output, a string. So I'm going to give it. So I'm going to give it a same return statement. And I'm just going to say call it name plus the statement was not an imposter. Okay, so let me just run this code again. So you can see that nothing happens because I haven't called any function. So I can call in one of both functions at the same time. So I can call in, let's say greeting div. So you get the expected result of hi div. So I can just throw div as well. So throw div. Okay, div was not an imposter. So you can also call functions inside other functions. For example, I could throw greeting div. Hi, div was not an imposter. So it will combine the output of the first function, which is hi div, into the second function as the input of the second function. And then the second function will then plug this into the return statement. So you get a combined statement, hi, div was not an imposter. So this is how functions work. And being able to call functions inside functions is an important part of Python. So I'm going to show you in the next few slides how to do that. So let me just go back to my my slides here. Okay. So now we know how to define functions. We need to decide when to use these functions and what to do inside the functions. So we do this by using branches and loops. So three of the most common ones are conditional branching, for example, if else. And we have loops, which is to repeat a statement certain number of times. So we have while, we have for. So let me just show you how this works in Wrapper. So let me just share my screen. Okay, so let me just define two new functions here. So let me just define a new function. So I'm going to call this function greeting2, and it's going to take in a name. So I'm going to skip the dot string here just to save time. So I'm going to first indent into the function, and I'm going to use an if-else statement. So if means it will do something when a condition is met. So let's say if, let me just not call this name, let me just call this greeting, or let's say greet. So if greet equals to hello, I'm going to indent return hello. So for the next one, I will use the term else if. Else if means that if it's not the second one, we can do something else. So you use else if. But Python will also accept the short form ELIF. So ELIF means else if. So let's say if this guy says goodbye, let's say this guy says bye, I'm going to say bye as well. And we can have one more else. So let's say this guy says something else that is not hello or bye. I'm going to just say, I don't understand. So you can see there's something going on here. Because there's an apostrophe here, so Python thinks that the string actually ends here. So in order to overcome this issue, I can use a double quotation mark outside. This will make Python detect the string correctly. So let me just run this code. Oh, okay, I forgot the colon here. So I need a semicolon after each of these. Just run it. Let me just put in here. And oops. Okay, so let me just try greeting2 and hello. So it's going to tell me hello. So let me just try it with bye. So let me just try it with hi. It's going to tell me I don't understand because it doesn't understand. So if you don't want to have double quotation marks, you can still use single quotation marks in your string, but in front of this apostrophe, type in a backslash. So the backslash is an escape clause. That means it tells Python to ignore this apostrophe. So when I run it, and I call in greeting2, let's say hi, and run it. you can see that the apostrophe is actually written properly this time. So this is how the escape clause works. Yeah. So let me just show you a little bit about how for and while works. So okay, so we can have a new function here, def adder. So this number is going to print out a large number of functions, a large number of numbers that I just written based on n. So I can say for I in range n. So I is an iteration variable. So I is going to decide how many iterations are there currently. Range n actually returns a series of numbers from 0 to n. So if I say range 10, it's going to return 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So one number before n minus 1. So I can say for I in range n, print I. And then return none. That means I don't want to return. I just want it to print out the 10 numbers. So you can also just ignore this return none symbol. It's going to work as well. Let me just indent it properly. Okay, so I'm going to run it. And I'm going to, let's say, call the function adder 10. So it's going to print out the numbers 0 to 9. So that's how the for function works. And I can also use the what you call the while function here. So I'm going to adder2. I'm going to define adder2 using while. While I is less than n, print I. But while is a little bit dangerous because while you usually lead to infinite loops unless you know how to stop the iterations properly. So let's say I is less than n. So the value of I is 0 because there is no definition of I. So I is a value of 0. While I is less than n, print I. But if I do not increase I after every iteration, it will never stop. And that will cause a lot of problems. Your system might crash. So usually what I will do is I will put in a clause here that actually increments the value of I by 1. So plus equal means I will increase the value of I by 1. So I'm going to run this. And I'm going to use adder2 10. Oops, sorry, I forgot to define I. So let me just I equals to 0 here and run it. So it prints out 0 to 9. So you can use for or while in many cases, but it does depend on your exact application about which one to choose. So let me just go back to my slides here. Okay, I think we are a bit short of time, so I'm going to move a bit faster. But let's show you a game here. So I guess you guys have seen, as a first example, I think you guys have seen this kind of motivational posts in the internet about how attitude is everything, how knowledge is not everything, skills is not everything. Yeah. So let's see if we can code this on Python. But before we code any programming, it's best to actually sit down and actually think of how we are going to ask the computer to execute this code. This is what we call computational thinking. So what we want to do is we want the interpreter to separate out the word into each letter. After that, convert each letter into a number. After this, add up all the numbers together and then return me the output. So it's sometimes nice to actually sketch out what you want the function to do before actually writing the function. Yeah. So let me just go to REPL and show you how I do this little game. So let me just go back to my REPL. So I'm going to just clear out everything here. And I'm going to define a new function called word score. So word score is going to take one argument, which is word, open semicolon. So I'm going to define the letters I'm going to use. So I'm going to use, let's call it list. And in list, I'm going to write down all the possible letters that I'm going to use. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So there are other ways to do it, but this is the easiest way I could think of. And we are going to use a for loop. So a for loop to take out every single letter inside the word. So let's say I'm going to use the variable I in word. So Python allows you to iterate inside strings. So if I iterate the string word here, it's going to read every single letter. And I'm going to just print I. So just to make sure that this function is working properly. So let me just run this function, and I'm going to use word score attitude. So you see that it actually prints out every single letter of the word. Okay, so first step completed. So second step, I want to convert all these letters into their corresponding number. So I'm going to just hide this print I for a while. So what I do is I will type in the hash symbol. So this actually turns this into a comment. So a comment is not implemented by Python. It's going to be just for reference. So I can just comment out this line and it will not be run. So the next thing is I want it to detect the score. All right, the score of what is the score of each letter. So I'm going to do it by using a specific method. We call this method. So I'm going to type in list, which is going to be this list here, dot. So the dot will call a method of some object. So I'm going to call in dot and then index. Index means the position of this list. So it's going to detect I, and it's going to detect where I is inside this list. So it will return me an integer. So I'm going to type in score list dot index I, and then I'm going to print score. Let's just see what happens here. So I'm going to run it. So I'm going to run word score of attitude again. Okay. So it prints out this number. So a series of numbers representing the positions in the list. So seems like it's working. So let me just go to the next step. So now I'm going to add up all the numbers together to get the final total. So what happens is I'm going to just add in the plus symbol here. So plus equal means add the previous score with this new number. So do it as long as there are letters remaining inside word. So I'm going to just run and then word score attitude. Oops, sorry, I forgot to give it a starting number. So I'm going to give it 0 here, and then I'm going to just run it again. All right, so I get a total of 92. There's something wrong here. So what's wrong here is that actually in the list, Python starts with 0 as the index. So the letter A is given the number 0. So in order to actually solve this problem, the easiest way is to give it a space. That means that the space is now 0, A is now 1, B is now 2, C is now 3, and so on. So let's see if it works properly now. So let me just score attitude here. So it's now going to give me the correct answer of 100. Yeah. So I don't actually need to print out the whole score. I just need to return the total at the end. So the last step is to actually give it a return statement, score. So you can enclose in brackets or no brackets, is up to you. So I can just do it again. So I have a final function, word score, attitude. So I get 100. So this is the final function that I was trying to do in the first place. So it's actually good to break down the function into steps that you want to have you want to define some steps before you actually start coding, and it will make your life much easier. Trust me. All right, so let me see if I have any questions before I move on. Okay, can you zoom in a bit? All right, let me just zoom in a little. Right. Maybe I'm being gone a little bit overboard. Can you guys see clearer now? Okay, so I'm going to leave this up here. So in case you want to have a look on this or you want to try yourself, you can have a look. But I'm just going to so you guys can try it. But I'm just going to show you some major flaw of this function here. So just now I actually try with attitude in capital letters. What if I change it to small letters? it's not going to work. Value error, and cannot find the string. I cannot find these letters. The reason is that in Python, capitalization is considered. So small letter A is different from capital letter A. So what I'm going to do now is I'm going to force Python to turn the whole word uppercase. I'm going to fix it to be uppercase. I don't care how the user inputs it. I'm going to change it to upper. And I do that by calling the upper method. So if the dot is to call a method, and upper is the name of the method, and then open close bracket. So all methods must have an open close bracket, whether it has an input or not. So let me just run it. Okay, so let me just try again if it works this time. So let's say word score, attitude, small letters. Oops, I think I did some mistake here. It should be just small letter U. And let me just try again, word score, attitude. Okay, so now it works properly. So this is what we call defensive programming, because sometimes you have no idea how the user is going to use your functions. So you might say, let's say you might have fixed it, say you must put in capital letters, but the user's actions is unpredictable. They might want to try something else different, or they might not actually read the instructions properly. And so now it actually works even if you, for example, if I make a mixture of small and capital letters, it will still give you the same answer. Yeah. So this is actually a form of defensive programming. So let me go back to my slides where I actually tell you this in the slides. So you can have a look there. All right, so as you can see, I have shown you how I actually force the input to be uppercase, and now it will work with any kind of case. So let's try some engineering kind of applications for Python, because I've been talking about word games and so on. So is it something that I use for fun? So I'm going to show you an implementation of the bisection method. So the bisection method is a way to find the root of a function fx equals to 0. So we have a quadratic equation here, and I want to find the roots of this quadratic equation. So the bisection methods work. The bisection method actually works by actually having two initial guesses. So I need A and B, and A and B must enclose the root of the function. So in this case, there are two roots. So I choose the positive root here, and I will slowly narrow down until I get to a very close to the root. So I'm going to do this implementation here. So let me just go back to my repo screen here, and I'm going to share with you this screen, and I'm going to just remove word score here. I'm sorry, but I'm just going to remove you. I'm going to define a new function bisection. But before that, I'm going to just define the function itself as an external function. This is because I might want to use this bisection method again in the future. So if I define the function externally, it's going to make it easier, because next time I don't have to modify the bisection method anymore. I just have to use the function. I just have to change this function externally. So I don't have to change anything that's inside bisection now. So I'm going to define a new function. So this function will do nothing but just to return the value. So x squared plus x minus 6. So this function does nothing but just to calculate the value of the function, the equation, x squared minus plus x minus 6. And remember that the exponent symbol is a double asterisk. It's not the exponent symbol. So now I'm going to code the bisection method. So the bisection method will use 3 arguments, A, B, which are the upper and lower initial guesses, and also the number of iterations. So I must stop this bisection method somewhere. Otherwise, it will go on infinitely, and it might never stop. So I need to stop it within a certain number of iterations. It is always common practice to limit in case the function doesn't work properly, I want to stop it after a certain number of iterations has passed. I don't want to have it run infinitely, otherwise it will crash your computer. Right? So I'm going to just define this function. So this function requires the midpoint of A and B. So I'm going to just define the midpoint of A and B, which is A plus B equals to 2. Simple as that. And I'm going to use a for loop here. So for n, for I in range n. So I want to stop it after once n iterations have passed. So I don't want it to go on forever. I'm going to calculate the midpoint of the function here. So remember that you must indent by typing 2 spaces after 4, just to make sure that it reads actually this statement as being inside 4. Yeah. So I'm going to code in the 3 statements. So there are 3 statements that I'm going to use here. One of them is actually if fxmid. So fxmid is actually calling the external function fx, which I defined here. So you can see that it actually tells you that there is actually this external function multiplied by fa is less than 0. I'm going to set a to the xmid. And I'm going to increment I by 1. So make sure that, because you can see if it's actually inside 4, I'm going to need another indentation level just to make sure that it's read properly here. So I'm a little bit lazy, so I'm just going to copy this for the next one. And I'm going to go back to the outer indentation here. So I'm going to just, I'm going to just go back to outer indentation. So make sure they're on the same level. And I'm going to change this to ELIF, else if. So for any if else loop, you must only have one if, one else. But you can have as many ELIFs as you want, but only one if and one else. So I have one if, I can have multiple ELIFs, but in this case, I only have one. So I'm going to change this sign upper to more than, and I'm going to change this to B. So there is a special case here, which is if I have already achieved, or I have already calculated the root, I've already reached the root. That means if I have already reached the root, this multiplication will be exactly equal to 0. So if I manage to reach the exact root, I don't want to keep iterating anymore. I just want the exact root to be reported, to be returned by the function. So I'm going to use the keyword return. I'm just going to print out a statement, say exact root, and I'm going to return the value of xmid here. Return xmid. So if I put in the return inside this ELIF, it's going to directly return it to the console, and it's not going to read anymore after that. So if any things happening after that, it's not going to be interpreted. So finally, just to make it safer, I'm going to have an else here. In case the user types in some funny inputs, I'm just going to return error. Yeah. So I'm just going to return an error here. And finally, this function is a return. So in case the function is working normally, I want to return the xmid. So this will be the actual value of the solution. All right. So have a look at the middle values. I'm going to just print out the middle values here, and I will just copy down here. So let me just run. See any errors? Okay, no errors yet. So let me just have bisection. So the bisection has the function has 3 arguments. So upper and lower guesses and number of maximum iterations. So I'm going to just put in 0 and 5. That's an initial guess, and maximum 10 iterations. So you can see that, oh, okay, finally reaches 2.504, something like that. Yeah, so this is how the bisection method works. So maybe you can try with maybe 20 iterations, and let's see how much it goes. Okay, so it gives you a more accurate answer, but you will notice that after a certain number of decimals, Python doesn't care anymore. So Python actually just throw away all the decimals after this, or this is what we call truncation, which means that actually Python actually limits the calculation to a certain number of decimals. So you have to be careful if you are using very small decimal numbers. Some of them might disappear after a few iterations. So this is something that you can have a look. Yeah. Okay, so let me just, if you have any questions about the root finding method that I presented here, let me know in the chat box. Otherwise, I'm going to go to the next and final hands-on exercise for today. All right, so if you have some prior knowledge of Python, you will know about what is SciPy, SCIPY, SciPy. And the bisection method is actually available in SciPy. So you don't have to code in your own bisection method. You can just use this built-in bisection method, but you have to import the SciPy library to do that. So what is SciPy? Now I'm going to show you what are known as Python libraries. So the main attraction of Python is that a lot of the functions that we use normally,
sir, I have a question, sir.
They are already written by someone else. So when they are written by someone else, they are ready-made and they are safe in this kind of libraries. So in libraries, we can actually just import this something that we can just import this library into our Python code and we can just use it. So a few of these Python libraries or modules that you can import are random, NumPy, SciPy, and matplotlib. So random actually allows you to generate a random number. So NumPy is for mathematics and statistics applications. SciPy is for certain engineering applications as well as some mathematics. And matplotlib allows you to draw graphs, just like in MATLAB. So the way matplotlib draws graphs is actually the same as MATLAB. So you use almost exactly the same code. So if you know MATLAB, you know how to use matplotlib. So you can, but you do have to import them before using. You do have to import them before using. And you can also import the whole library or just parts of it. So let me just show you an example of how I import an external library. So this guy here, he wants to play rock, paper, scissors. So I'm just going to show you how I import the random module. Yeah. So this is a bit long here. So I'm going to show you in REPL how I'm going to do that. Let me just share screen here. Okay, so let me just share screen here. So I'm just going to, let's say, import random. So when I run it, nothing happens because I have just imported the random library, but I have not used anything to it, to do it. So let's say I can define, let's say something like x equals to r, the strings r, p, s. And I'm going to just choose one of them. So random.choice actually returns one of the elements inside this tuple. So I can just run it and nothing happens because I did not ask it to print. So let me just print it. Okay, so let me just see if this works. So it returns, so every time I run it, it returns a different string from the 3 choices that are inside the list. So that's how it works. Yeah. So random.choice will return a random choice and random element inside the list. So let me just copy and paste my my implementation of the this rock paper scissors game. I'm a bit lazy to get you put the whole thing here because you're running out of time here. So this code is available inside the handout that I gave previously. Yeah. So let me just type in gg.gg. So if you want to have a handout, please use the link below and you can access the handout. So I'm just going to show you my pre-prepared implementation of the rock paper scissors game here. So you can see the import random keyword here, and I'm going to run it. So I have defined as a RPS. So a function name is called RPS. So I can just type in RPS. So I'm going to play rock here. Oops, sorry, forgot this. So you can see that it actually draws. So draw, lose, win, lose, win. So every time I type in, I call the function, it returns a random, different kind of output. So that's how I play rock, paper, scissors with Python. If you have nothing to do in the pandemic, well, you can just have a try. So it's just a way of spending time with you. Okay, so I think I've covered the basics of Python, and we are running slightly above the time schedule. But I'm just going to show you how we can use NumPy and SciPy for matrix applications, for equation solving, and so on. So this guy here, Dave, he has some mathematics homework that he wants us to solve for him. All right, so we are going to do that. So let's say we have this guy has 8 students. This class has 8 students, and we want to find the mean, standard deviation, and variance. So what happens is that you can actually import this data set you can just import NumPy first, and you can put in this data as an array. So array is a special data type inside NumPy. So NumPy has the array data set, a data type that allows you for a lot of these statistic applications. So you can just print out, and you can see the expected values here. So let me just try it out just to show you that it works here. So let me go to my example. Okay, so I'm going to just copy and paste into my REPL page here. So I'm just going to show you using my REPL here. Okay, so you guys can see my latest REPL.it console. So in this case, I use import NumPy SMP. So I can actually just type in import NumPy, but because I'm a bit lazy to keep typing 5 letters, I can just type in SMP. And for any function that I call, I can just use np dot the function name. Yeah, so that's why I import SMP. So in this case, I need to print out the minimum value, maximum value, mean, standard deviation, variance. So let me just run it. And you can see that the NumPy array is printed out. Minimum, maximum, mean, standard deviation, variance. So this is how NumPy is used in statistics applications. Very simple. Just type in just import NumPy and just use the ready-made functions. So simple as that. So let me go back to my screen here. Okay, so let me just go back to my screen, my slideshow here. And another possible way of using it is to solve certain mathematical equations. For example, in this case, I have a 3 equation system, linear equation system, and I want to solve it using matrices. So usually I have to calculate the inverse, multiply by the answer, and then I get the solution. So this is actually finding the inverse of a matrix can be quite difficult. So what I can do is I can just import SciPy. So SciPy allows for linear matrix manipulations. So I'm just going to show you how I do it in my example here. And I'm just going to copy paste my pre-prepared code here just to share with you. So let me just share screen again. Okay, so you can see that I have copy pasted my code inside here. So first I have to import NumPy as NP. So the second line, I import SciPy. But in this case, SciPy is a very big library. I don't have to use all functions of SciPy. I just need to use the linear algebra function. So I can just type in from SciPy, import lin-ALG. So this is a linear algebra matrix manipulation function. And I can calculate the inverse of the matrix. I can print out the answer, matrix manipulation, or I can directly use the solve function to just give me the answer. So I'm just going to run this, and I'm going to show you how it works. Okay, so let me just open it a little. So you can see that it calculates the inverse of the matrix. And the first method where I manually actually multiply the inverse by the right-hand side matrix, or the second method where I just use the solve function and then input 2 NumPy arrays, then it will give me the answer directly. So simple as that. So this is the power of SciPy. So no need to code yourself MATLAB, how to type everything in MATLAB. Just import SciPy and then pop, drop in the input, output comes out immediately. Simple as that. So this is one of the powerful functions of Python, where because you have these ready-made libraries. Yeah. So let me just go back to my slides here and give you the final example, which is where I use matplotlib to plot this curve. So in Python, you can plot graphics. You can plot certain graphics, and you use that by using the matplotlib library. So I'm going to show you this example, but in this case, I'm going to share my local Spider IDE, just because it has an easier way of actually showing the plot here. So you guys can see my Spider IDE, right? So this was a Spider IDE that I introduced at the start of the presentation. And you can see that on the left side here, I have let me just zoom in a little, it's quite small. Okay, so I've just zoomed in a little. So you can see that I just import NumPy as MP. From SciPy, I import MISC. So this actually, I'll show you later what this means. And I actually import matplotlib.pyplot as PLT. So PLT is again the short form because I don't want to type in pyplot, it's quite long. So I can just run this code. Let me just find the run button here and run file. So you can see that the first is a photo of a raccoon. So this is actually an Easter egg that's inside Python. So how you actually plot this is that you actually call in the misc.face method. You save it inside some variable, and then you show the plot, and then you get this. So this is actually just a joke that the Python developers implemented. So the second one is where I show you the curve and the actual data. So I actually created two NumPy arrays here, X and Y. So X and Y are some data set, there's some data points, and I want to curve fit. I want to fit a curve into this 8 data and give me the best fit curve. So you use them by using curve fit. So curve fit is in SciPy. So curve fit is a SciPy function. And you can see there's a keyword func func here. So this is actually externally defined. So I externally define this function. So I can change this function and the curve fit will change accordingly. And I print out the coefficients of this function. So you can see in the console here, I have 3 numbers. So these 3 numbers are actually the coefficients A, B, and C for the curve fitting function. And I also use the final 4 lines to plot the original data and also the fitted curve. So if you are familiar with MATLAB and how we plot things in MATLAB, this is almost exactly, I would say exactly the same as how you plot something in MATLAB. So you have plot X data, Y data. This code represents the color and the type of the plot. So B means blue color, dash means line. So that means I want the curve to be a line, and the label. So it's labeled as curve fit. So the second plot here, so I can actually plot 2 different curves on one single graph. X data, Y data, RO. So R means red, O means circle. So I use circle to represent the original data fit, original data points, and then I label as actual data. So you can see the curve on the window here. I can toggle between the 2 curves here, 2 plots here, and there's a legend, there's an x-axis, y-axis here. Finally, but I do have to enable the legend, and finally I have to show the plot to export the plot to the user screen. So this is how you would draw something in Python. If you are familiar with MATLAB, this is almost exactly the same as MATLAB. So, and that is also why I say if you know one language, it does make it easy to learn another object-oriented programming language. Yeah. So this is the same curve that you see in my spider screen. So I'm nearing the end of my presentation now. So usually I receive a lot of questions about where can I learn more about Python. The way I learn is actually from online courses like edX, Coursera, Udemy, Udacity. Among these, I recommend Udemy. It's the cheapest. I think for 12 USD, you can get full Python package. You can get some free ones, but the free ones are, by my experience, not that good anyway. I would recommend you just to fork out a little money, $5, $10, just to have and complete the course. Make sure you complete the whole course. Don't give up in the middle, and you'll be a Python expert in no time. So there are many Python courses available on the internet. You can have a look, but just be careful if you are paying any money, you don't get tricked by someone. After you have mastered the basics of Python, I recommend the following 4 resources down here. So python.org is the official website for Python. So if you have something, you want to know what type of data types are available, what are the objects and so on, you can go to python.org. They have all the full documentation about how to use objects, how to use certain variables and so on. W3 Schools and Learn Python are free tutorials that you can, for example, you want to do something. For example, I want to do the bisection method. You can go to W3 Schools and find someone has coded this exact bisection method for you, exactly the whole thing. So you can have a look and you can modify from them to suit your own needs. Yeah. The last one is Stack Exchange. So Stack Exchange is a forum. So if you have a problem with your Python code, you can post your whole code onto Stack Exchange and you can ask questions. And usually people will respond to you. Yeah, so I find the Stack Exchange is pretty nice. People are usually very helpful, and they will actually go explain exactly what are your mistakes that made you unable to actually run your Python code, for example. So these are a few resources that I recommend. There are some more new ones like I think LinkedIn Learning. LinkedIn Learning does have a few Python kind of tutorials, but I do think they're a bit expensive, to be honest, because I think Udemy is much cheaper. I think LinkedIn Learning you have to pay like $40 per month, something like that. So there are actually a lot more, and there are hundreds, thousands, and this is not exhaustive list, but these are a few that I personally have used, and I will recommend you guys if you want to learn more about Python in the real life applications. I recommend these few resources. Okay, so just to summarize my presentation here, so a few key takeaways from the presentation. So welcome to Python. Python is the easiest to learn programming language, to be honest. And just master the simple elements of Python, for example, variables, data types, functions, operators, and so on. And that's all for me, guys. So thank you very much for listening to me on your Saturday morning. And I think I'll pass back to the MC for any questions. Thank you very much.
All right, thank you very much, Mr. Teo Wei Jian, for the informative presentation. Now we shall move on to the Q&A session. All right, so before we proceed, here's a request to all participants. Please ask questions only by typing through the Mentimeter website with the entrance code as 86546287 or by clicking the link provided in the chat box. Turning on your microphone is not allowed to avoid interruption during the session. All right, so I can see that there are a few questions here from the participants. So the first question would be, is Python an essential skill for chemical engineers?
All right, thank you, Ghana. So that's a difficult question to answer, to be honest. It's more difficult than it looks. Is Python an essential skill for chemical engineers? I would say it is a skill. It is a skill. Whether it's essential or not does depend on which industry you're in and how you are using it. So if you are in a, let's say in a design kind of industry, you might not use Python at all. But if you are in the R&D industry, you are in a manufacturing industry, you might use Python for certain machine learning kind of applications, machine vision, AI, neural network kind of applications. So is it essential? I would say not yet, but it is something that is upcoming, and Python is getting more and more momentum in the industry as a programming language to be used in the industry. I think Malaysia is probably lagging behind when compared to certain Western countries, for example. But I would suggest you at least equip yourself with a skill that is useful in the near future. So Python can be a skill that can be accessed to yourself in the near future. Yeah.
All right, so thank you for the answer, Mr. Teo Wei Jian. All right, so the next question would be, what are the differences and similarities between using MATLAB and Python?
Okay, so what are the differences and similarities between MATLAB and Python? So MATLAB is a programming language. It is an object-oriented programming language, similar to Python. If you know Python, you will know MATLAB, and vice versa. The difference between MATLAB and Python when it comes to scientific computing applications, because MATLAB is a scientific engineering software for statistics, for matrix manipulations, for electrical engineering, and so on, is that a lot of these functions are natively available in MATLAB. That means if I want to do some matrix manipulation, I can just type in the matrix and manipulate just like that. But Python does not have matrix manipulations directly. You do have to import the SciPy library. As I shown in the example just now, you do have to import the SciPy library. And then you can do matrix manipulations. Of course, the syntax is a bit different. The way that you do matrix manipulations is a little bit different. But I would say Python is an open source language, so you could actually do more things with Python than MATLAB. And best of all is that Python is free. MATLAB is not free. MATLAB is a very expensive piece of software. Yeah. So yeah, that's my answer to that.
All right, thank you for the answer. Next question. Okay, how to connect our Python coding with GUI?
Okay, so I'm going to assume GUI means graphical user interface. So how to connect your Python coding with GUI? That is beyond the scope of this webinar. And to be honest, quite beyond the scope of my knowledge in Python. It's something that I'm also exploring. But the simple answer is yes, you can. You can have a GUI in Python. You can integrate it with other applications like Excel, MATLAB. You can even write in your own GUI, your own way to input. You can also import data from other files like text files, like CSV, spreadsheets, for example. So Python is very versatile, and yes, you can actually connect them with a GUI, and you can import external data to be analyzed in Python.
All right, thank you for the answer, Mr. Teo, Vijay. Okay, so next question. All right, I heard that Python is very convenient as compared to other programmings. However, might be heavy on the CPU. Hence, are there any platforms where one can use to practice or any device? Sorry, any advice?
Python is convenient, that's correct. Yes, that's a good observation there. Compared to other programming languages, yeah, correct. However, it might be heavy on the CPU. Python is not heavier than any other programming language. It is technically actually even lighter, a little bit lighter, but it does depend on how you actually code in your functions. For example, there's a concept called order. Order will decide on how CPU intensive your functions are. But for a general statement, I would say Python is actually very light on your CPU. So if you have a very old laptop or a very simple laptop or computer, you don't have to have a gaming laptop just to run Python. And anything that can run a browser will be able to run Python, as long as you don't give it some crazy number of iterations, for example, 10,000 or 1 million. I'm pretty sure Python is able to run on any computer for any normal kind of application. Yeah.
All right. So next question. Okay. What specific areas of Python would you recommend for us as chemical engineers to focus on?
Okay, so specific areas. Of course, you must first know the basics of the Python. For example, the 4 components that I mentioned: variables, operators, functions, loops. You must know the basics. And specific areas, I would say NumPy and SciPy. That's why I purposely introduced them. There are actually many other libraries for other applications, like maybe for web design, for app development. There are other libraries that can be used. But for many applications in engineering, I would say NumPy and SciPy, because you can solve equations, you can solve metric systems, you can solve for example, thermodynamics kind of applications, you can solve for fluid mechanics and so on. So I would say focus on NumPy and SciPy.
All right. Okay, so we'll proceed to the next question. Why Python, not Viper?
Why Python, not Viper? I think I receive a lot of questions. Why Python, not Anaconda? Why Python, not Cobra? My answer to that will be that Python is not actually named after a snake. So that's why it's not called Viper or Anaconda or Cobra. So what is Python named after? You can look in my handout, in the slides, PDF slides that I posted, and scroll to the last slide. There you will find the origin of the name Python. And it is not a snake. So that's why it's not Viper, it's not Anaconda, it's not Cobra, and so on. Yeah, so that's my answer to that. Please discover the answer in my handouts.
All right, sure. We'll have a look at the handout later. All right, so next question. Other than Jupyter, what are good Python environments for data science?
Okay, Jupyter is something I don't really use that much because I'm not a data scientist. So if you're starting out in data science, I recommend just downloading the Anaconda package. So why not Python? But I have no idea why they call it Anaconda, but whatever. It's not named by me after all. So you can download Anaconda on your computer. It's 100 megabytes, very small file. You can install Spider and you can use it as a starting. So Jupyter might be a little bit more difficult for a beginner, but it's also quite easy to use, I would say. So one alternative is Anaconda or Spider.
All right. Okay, I think maybe we can have another 2 more questions before we call it a day. Okay. How widely used is Python programming in the digital world?
How widely used is Python programming? I would say is the most widely used language. As I showed some statistics in the previous slide, Python is used by more than 25% alone when it comes to coding. And there are a lot of books out there for Python. There are a lot of resources out there for Python. It's just how to choose between the best resources when it comes to learning Python. So, and also Python has a lot of libraries. So libraries are something that other people, it's a work of other people and you just import it and use it. There are also libraries for machine learning, for AI, for data science, for neural networks. So there's actually a complete AI code that you can just download and apply by yourself. So I think that there's no doubt that Python is the most widely used programming language in the digital world. And for some other, if you want to know just how widely Python is used, I recommend some books. For example, I have one book here. Let me just show you a little bit. So this is not a digital background. This is my real cupboard here. So you can see this book here, Data Science for Python for Dummies. So I recommend this book if you are thinking of using learning Python in data science. And this is one of the better books. I bought it quite cheaply. So because there was a sale. So there are also a lot of free ebooks out there if you don't want to spend a single cent just to know how widely used Python is in the digital world. Yeah, so that's my answer to that.
All right. So final question would be, can I use Python for programming sensors?
Yes, Python is used in IoT applications for sensors and actuators and also for the controls and so on. So if you have an Arduino board, if you buy an Arduino board, Arduino Uno, for example, they will use Arduino language. But there are also other boards that support Python. So it does depend on how exactly you implement it. So yeah, that's my answer to that.
All right, so thank you, Mr. Teo Wei Jen, for answering all the questions raised by the participants. And also thank you everyone for participating in this session. So now we shall move to the photo shooting session together with Mr. Teo Wei Jen. So to everyone, kindly turn on your camera now for the photo shooting session.
Okay, everyone, please smile and stay for a while. I will start to take photos after all of you open your camera.
Just give me a thumbs up, shall we?
I'll start taking photos now. Everyone, please smile and stay for a while. All right, thank you, everyone.
Thank you very much for the session. I really enjoyed it. There are a lot of unanswered questions. I'm very sorry if I couldn't take all of them because of time constraints, but I'm going to just drop in my my LinkedIn profile and my email address here. So if you guys have still, I see a lot of questions. So if you guys have any more questions, please drop me an email. Feel free to drop me an email. I'm happy to answer any and all questions that you have. And let's connect on LinkedIn. So I just dropped my LinkedIn profile inside the chat box. So if any more any questions, or you have some thoughts about how to use Python in a specific kind of application, but you have no idea how to start, just drop me a message. I'm happy to just respond to them. And if I can help you, I will at least give you some tips about how to start, or I will link you to some resources that are relevant to what you're trying to do. And I wish you all the best and happy coding.
All right, thank you so much, Mr. Teo Wei Jian. All right, so with this, the webinar session has come to an end. We would like to thank Mr. Teo Wei Jian again for sharing his knowledge with us today. We are glad to have you as our speaker and wish you all the best. To our participants, thank you all for joining this event. You're all welcome to fill in the feedback form for today's event by scanning the QR code provided on the presenter's slide, or by clicking the link provided in the chat box. Also, kindly fill in the attendance form in the chat box as well if you haven't done so, as e-certificates will only be given to those who fill in the attendance form. So lastly, goodbye, and we hope to see you all again soon. Have a nice day ahead. Thank you.